Josh Carroll, who also helps, is out of town this week, so it's just me. I want to thank our sponsors, RecruitWise, for providing soda, pizza. Back there, there's Glenn. Let's thank Stalworks for letting us meet here. So not only do they let us meet here for free, but they're normally closed on Monday, so they open up just for us. So we're going to be here for a while. So I suggest you join the Koozie Club like I did and get some deals on some beer. So it'll be worth it because we're going to be here for a while. Everyone rush up there now. So this month we got Jared Smith from UTK, Hack UTK, a bunch of other stuff. He does everything, it seems, always everywhere. So he's going to give a talk on cybersecurity. So I'm just going to get out of the way now.
Thank you, Chris. Yeah, my name's Jared. Let's see, I guess we'll get started. So my talk is really lame, corny. Most of cybersecurity has like buzzwords out the wazoo. So you'll hear me saying like cyber warfare, breach, data, like all this crap all the time. Like it's really sad that our field is like devolved into that, but it's still a great place to be. So we're talking about hacking your own systems before they do first, where the people that are hacking them are those bad guys that we all hate. So a little bit about me. I'm a security researcher and software engineer intern at Oak Ridge National Lab in the cyber warfare research team. I was formerly at Cisco's Advanced Security Initiatives group doing security work as well. I'm a senior in honors computer science at UT, president co-founder of HackDK, which is a computer security club that we just started last fall, and we have about 120 members now. They're on our email list and do actively participate. We had one big event last semester that had upwards of 50 people come. We have several huge sponsors that provide us a lot of stuff, which is great. And then I did some consulting for startups on the side, both through the KC and on my own, a startup in Nashville, a cybersecurity startup in Toronto, and a few other places. So that's me in Machu Picchu. I was just there in Peru last December. I went with one of my friends that's actually here, and we went to build they're called safe cook stoves, just basically stoves out of pig dung, like in the middle of nowhere in Peru. But while we were there, we got to do some awesome stuff like at Machu Picchu, just through the university. And then that was our first meeting with HackDK. We had a bunch of people, and it's since grown. But yeah, that's a little bit about me. Before we, I guess now let's actually get started. So I'm going to give a kind of a picture of a slightly satirical day in the life of an ordinary developer in a time of crisis. So it's kind of supposed to be, it's very satirical, but so the lead developer says, hey boss, we've been building this app for a long time. It's taken us forever. We're super excited to push it out. Can we please push it out? Manager says, hey, let me check with all the people in the company, get through all that red tape, get to the top and deploy this. So every developer's happy. And next day at the all hands meeting, the CTO comes out and says, hey, let's deploy this. Let's finally push it. So they launch it. Developer goes to his keyboard, pushes to the release branch, blah, blah, tests all pass, your continuous integration passes because we all use that. Finally, it goes out to the release and it's there. So Slackbot also laughs and it's like, hey, celebrate. Then 6 months later, everything's been going fine, making bank on this app. And all of a sudden, there's a massive leak of credit card numbers and plain text passwords because we all don't encrypt our passwords. Hackers breached the internal systems as well. So Slackbot is now telling everyone to send them 1,000 Bitcoins to this wallet, and you have to pay that just to get your bot back on your internal servers. And everyone proceeds just to freak out. So this is what happens when we don't correctly take security into our mind, even just the least level. So that's, again, I thought that was fitting because this is what happens when the ops teams start freaking out, complaining at the developers, saying they broke the systems, and the managers freak out, throw around a bunch of buzzwords. So this is basically how it happens. So there's a really good quote by a former national security guy that was led a bunch of stuff in the US, blah, blah. He said, if you spend more on coffee than IT security, you will be hacked. What's more, you deserve to be hacked. I found this while just looking for quotes in security because I don't really go looking for those much, but when I found this, I was like, that's actually really, it's pretty true, because if you really do spend a ton of money on everything and nothing on security, then stuff's going to happen, and it's going to happen faster and sooner than you know it. And so that's why I'm kind of giving you guys an intro today on some of this stuff to hopefully help you not make these mistakes. It's kind of, and it's also tailored to developers and managers. It's good to know this stuff regardless. And it won't be like a deep dive to where it's all technical. It's pretty mile high, inch deep, so it should be out to everybody. So obviously security is a problem, and we don't really focus too much on it. So here's a good picture. It's kind of cut off, but it's showing the world's biggest data breaches. This chart actually goes way down the screen. If you just Google that exact title, world's biggest data breaches, you'll find this. And this is, I don't know how far back this is, but okay, so updated on the 5th of February 2015. This was the amount of records breached at some of these companies. This is the very top. So eBay, 145 million. If you look more into here, there's Snapchat, Mac rumors. If anyone has a Mac and checks out posts they have in there, that might have happened to you. Mozilla, how many of you guys use Firefox? That's obviously something going on. Obviously, we see there's a problem, but why are these mistakes being made? If you go and look at a lot of these incidents, there's one down here a little lower, LinkedIn, that I'll talk about later. There's such simple mistakes to avoid, just so simple that if you just knew the basics, they wouldn't have happened. And a lot of the time, the reason these pass through production, get out to the real world, and are sitting out there is because there isn't a focus on security, and nobody wants to spend money on something that doesn't bring in money immediately. But the problem is that stuff will happen, and when it does, you're going to lose money. So I mean, I'm a security person, so I think spending money on it is good. But that's the problem. There's a lot of people that think you're going to lose money by devoting resources to it. But hopefully, you'll save money in the end. So a few notable examples. So Heartbleed was the one that came out, let's see, 2014 fall or so. An interesting statistic with this is that this vulnerability was pushed out to production in December of 2012. It was merged in December 2012. And was not discovered by anyone and reported until January of 2014. So for 2 years, I could hop onto any of your servers, any of them, even they just have to be Linux. So if you run Ubuntu, CentOS, whatever, I guarantee you have them. I could hop on, send a little packet to your computer, and read all of the data off, your private keys, any credit card info, any passwords. It would just dump me all of the memory off of your computer. And that was out there for 2 years. Who knows who knew about it? The government, other countries. But sure, companies didn't know anything about it. And if they did, they didn't report it. So that's kind of an example of what happens when we don't put security at the forefront of our mind. And once that happened, patches were released within the day. I remember I was a sophomore maybe at UT, and it was just crazy. Everyone was freaking out about this, and we didn't have much to worry about because we maybe had a few like VPSs or something, a few servers of our own. But huge companies had thousands and thousands of vulnerable servers just because someone way back 2 years before didn't really review their code well enough. And that's the problem when you don't consider security. So there's obviously been others. Shell shock was more recently, had to do with bash, the shell. SSL v3, the Poodle attack, was degradation of SSL connections to do basically bad stuff to your HTTPS website. So all those green locks you see just worthless when you could utilize this. Let's see, this was Ghost. I don't really know much about that one, but it was another 0 day. And when I refer to 0 day, it means it's a vulnerability that exists that nobody knows about or that hasn't been reported publicly. So people might know about it, but it's not reported publicly. So you and me wouldn't know, but I mean the NSA might, or Google's teams might, and they might be breaching Amazon's stuff and reading their data and not telling them and making money off of it. Like this does happen. It definitely happens. Stage fright was the one that just happened this past year on Android phones, and you could do really bad stuff to them. Let's see. So, and then we all know about Flash, tons of Flash and WordPress, many more WordPress vulnerabilities. I don't mean to bring down those platforms, but I mean, unfortunately, when you iterate that quickly and you push a new version every 3 minutes, there's going to be vulnerabilities. So I guess I have to go through. Wait, no. Yeah, I do. Okay, so again, there's obviously more Flash and more WordPress. Okay, so it's obviously inevitable. Breaches will happen. You saw all of those big circles. I told you it keeps going down. You can Google data breaches 2015. You'll see hundreds. You can Google, keep going back and just keep looking and looking. I mean, the earliest reported viruses and worms went back into the beginning of the internet. And back then it was a lot more harmless. People just did stuff just to mess with people. So an example of that was there was a Sammy worm. If any of you use MySpace, this propagated from one user to almost the entire network of, I don't want to make a number up, but it was many, many people, almost the entire website. This guy injected a script into the application, and he made everyone's profile say, I love Sammy, and the guy's name was Sammy Kumkar. And it propagated to hundreds of thousands of people within a few days. And it just showed how quickly viruses could get out back then. And he was put in jail for a few years, for I don't know if it's a few years, a few months maybe. Now he's like, all these security podcasts come and talk to him about, like he's like a security expert now. I mean, he knows what he's doing, but it's kind of funny if you go and look at like the hacker security community. A lot of the early people that did these, that broke into systems like this, are now like renowned security experts and are looked to by the rest of the community. Because what they were doing wasn't necessarily unethical, but it was just taking advantage of companies that weren't really paying attention to security. So there's that. You can Google around famous hackers and stuff like that. And so we know it's a problem, we know it exists, and we also know it's hard. It's hard in the sense that security isn't easy to fix if you don't know anything about it. But I think where the hard part ends is once you just know about the basic parts of security, how to fix the smallest things. And more often than not, by fixing some of the smaller things, you end up protecting your attack surface by quite a bit. So there's a lot of domains of security. We'll just be talking about web today. But if we really wanted, we could go on for weeks and months and years about just learning network security, vehicle security, mobile security, Internet of Things security, embedded security, SCADA, which are industrial systems. So like nuclear power plants have devices. What if they get hacked? That's what happened with Stuxnet in Iran. The United States and Israel, what people think it was those two countries, had 4 0 days, so 4 vulnerabilities in Windows Server that no one knows about except for them. And they injected it into the machines in Iran's nuclear power plants and delayed the processing of of uranium by months, if not years. And they just took out their systems by doing this. And that's an example of SCADA systems. Another example of that is power grids. Just the other day, Ukraine's power grid, like half their country, their grids went down. And believe it or not, our country only has 3 main regions of power grids, and most of these systems are decades old. So I mean, we're just that far away from the next major breach. It doesn't just affect our passwords and stuff like Ashley Madison or eBay or LinkedIn, but it will literally affect our power. And people could do really bad things when that happens. So I think it's pretty important to consider just basic security vulnerabilities and how to fix them. I know I'm rambling, but it's really important to show all of this. There's a vehicle security center at Oak Ridge where we can like drive a car right up in this building, close all the doors. It's basically a big Faraday cage, and we can try and hack into the car. And people are trying to do that. Like I think it's the NTRC, and they're pushing to do more of that research there. So it's starting to get more known, but we're still inching along. We're not yet at that critical mass of knowing like, hey, this is a problem, let's fix it. And there's more domains of security. There's lots of articles about people's refrigerators getting hacked and your Nest temperature things getting hacked. And there was a Barbie doll kind of toy a few months ago that got hacked, and they could spy on kids with this Barbie doll because the people weren't encrypting the connection between the Barbie doll and their computers. So someone across your street could listen in on your open Wi-Fi and watch the video camera feed of the Barbie doll watching your kids play. So that's all because they didn't do one small configuration. Literally one line of code could have fixed that. They would just have to say, yes, encrypt this with SSL. That's all they would have had to do. No, they didn't do that. So all these kids got watched by their Barbie dolls, by their creepy neighbors. So it's like, this stuff happens and people don't really realize it. Another example is this kind of illustrates it a little bit more broadly. This is known as the TCPIP and the OSI model. Anyone familiar with networking would be familiar with this. Basically, you have your layers of the networks. That is, application layer is everything you might know as HTTP, stuff that makes our web applications look the way they do. And as you work your way down, you get all the way down to physical wires and ones and zeros and positive and negative charges being transmitted. So, 1 second. So this kind of illustrates at every one of these layers, we have the potential to introduce vulnerabilities into our system. So HTTP is very close to the top. And then there's SSL, that's where shell shock was introduced, or that's where Poodle was introduced. So you keep going down, and TCP, if you were to take out, if you do something to TCP or find a vulnerability in that protocol, that's how HTTP works, that's how we view any websites. Then imagine what you could do. You could take down and look at anything, mess around with anything that uses TCP, which is almost all of those things up there. You're familiar with ASCII, with IRC, with DDP is MeteorJS's data binding protocol that runs on top of TCP. WebSockets with JavaScript people, we love WebSockets, so there's that. SSH, all that stuff. So you keep working your way down, and you eventually get to stuff like IPsec. This is how corporate VPNs work. If you found a vulnerability in that, then I could just sit in between Cisco down the road from my house and just watch all of their stuff. I mean, it's more complicated than that, but that's the problems we have by not looking at security and focusing on them in these applications. And you may think, wow, I'm never going to work on the Ethernet protocol as a JavaScript developer, as a PHP developer, but you will definitely work on stuff that uses HTTP, and you will definitely work on stuff that might use SSH or HTTPS. So this is just to illustrate that this is really a problem, and we have to be focusing on this. So I may have sounded all doom and gloom, but there is definitely hope. There's hope if we know how to think like hackers, if we know how to think like people that are going to attack our application. If we know how to think outside of just, okay, I'm going to write this code, write this application, and be done with it. And I'm not coming from the perspective of never writing applications. I started, I'm in school at UTK, but I started doing software engineering at actually a legal analytics company working on the supercomputer at UT, doing development of parallel algorithms for genomics and computing patent, similarity between patents and stuff. And then I've done tons of Python apps. So I know where I'm coming from the building apps perspective. And it's been really great to do security and see where we're coming from the breaking down application. So if you think about both the building and the breaking, you can get this really nice merge of understanding how you can introduce vulnerabilities and how to combat them. So that's the classic black hat, white hat. The white hat is the good hackers, and the black hat is the bad people. So it's just, you kind of see that if you go look in the community more. So to think about the hacker mindset, we first have to begin with what is exactly a vulnerability. So it's basically when you make the application do something it's not supposed to. And to find out these vulnerabilities, you have to understand the application. And obviously for us developers, that's great because we wrote it, we built it, we know the people who built it, we can talk to them, they're at the desks down the hall. It's really easy for us to understand that. And that's a large part of the problem for people that are more attackers and pen testers, is that a lot of them haven't done development and software engineering in general. So I see this a lot in places I've interviewed and companies I've worked with, where they're very familiar with breaking applications, but they're really excited to hear that I've done a little bit of building applications myself, because apparently it's good to know how to build applications if you're doing security research. So that's really good for us. Now that we know how our applications are built, let's see if we can figure out how to break them. So you have to, again, know the application. So what is it meant to do? What's the behavior, what's the functionality, and the difference between those is functionalities, like what are your features, and what's the behavior, what happens when you use these features. What does the application use as input? So this is a very, very important point. If you understand just two things out of all of this, if you understand just what input goes into your application, where you can put input in, and how output comes out, you can basically deal with anything in the middle there and bend anything to your will with an application. That's the fundamental, that's how you think about attacking things. So that's basically here. You understand how it works. We all know that. And then you think about how you can get stuff into it and how stuff comes out. Let's see. So here's another important point. I don't think I skipped anything. Okay, so you also have to understand what if something is a vulnerability. So let's say you find that authenticated users can edit page content. That is supposed to say unauthenticated. Sorry about the typo. So unauthenticated users can edit page content. On CNN.com, that's a problem. You don't want me going into an article about Trump and saying, hey, Trump, you're the best man in the universe on CNN.com. But on Wikipedia, I don't care. I can go and edit whatever I want as an unauthenticated user, and someone can come in and correct me. That's just how the model works. So when you're looking at your applications, you have to know if something is a vulnerability and if something isn't. And this is also pretty easy to figure out as developers, because if you build a front page, if you have a public and private part of your website, if you figure out that you can break in to the private part when you're already logged in, then you don't have a vulnerability. But if you can break into it when you're not logged in, then there you go, you have a problem with your app. So that's just kind of something you have to keep in mind, and it's a pretty good distinction to be able to figure out those two things. Another thing that really helps with thinking like an attacker is that it's a process. So a lot of people in this contesting community, when they go and do an engagement with a customer, it could be any company, they'll get the application and they'll read through the documentation. If they have the source code, they might read through that, but then they just look at the whole application in general and start playing with it and using it and understanding it. For us, you don't really have to do that. We know how it works. So what you do is you do a bunch of reconnaissance, like, hey, test this feature. Can I log in here and mess around with the search? Can I make it do something? Give me something that I shouldn't have, blah, 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 blah. And then from there, once you do your reconnaissance, you look and see, hey, this looks kind of interesting to me. I have a gut feeling that this is something that sounds like it could be exploited. So you maybe find that when you hit a certain page, it tells you something about the underlying application, something you're not supposed to see. Then maybe you explore that farther. And once you're there, you can develop a hypothesis of what you think a vulnerability is. And from there, you test it, and if it works, you can develop an exploit, and then what we all do, we profit, we make money off of it, we sell it to the black market, we sell it to Google, we sell it to whoever. What you really do is turn it in, but that's basically the process of looking for vulnerabilities, developing a hypothesis, testing it, exploiting it, and then from there you disclose it, you do whatever you want to do with it. There's entire websites devoted to just facilitating things called bug bounties, where companies will pay people just to find holes in their website. And like the other day, Google paid out $10,000 or something to somebody just because they found that that you could. I'm trying to think if it was Google or Facebook, but Google is known to have payouts up to $40,000 for getting into an Android phone without. Can someone help? Do you know how much it is? Okay, it's a lot of money. If you go to bug bounty, they're called bug bounties, and if you go to bugcrowd.com, there's just like hundreds of companies that just say we'll give you money or swag or put you in our Hall of Fame just for breaking into our website. Swag is the best part because I just want shirts to wear around school. But there's that, and this is kind of a good process to know when you go about that. Okay, so back to the input part. This is really critical. You have to understand your vectors, the injection vectors, where you want to get input into the application. So that could be your form fields. That could be email. Basically, if you can send an email to a certain endpoint in the app, it says send your email here to get added to our list. Try and mess with that. If you can mess around with the cookies or put in posting things, state changing requests. If you can mess around with the URL path. Another problem that happened, this happened to AT&T actually. There's a famous hacker called Weave, where apparently AT&T put their, you could just go to the URL and put a number after the URL and get to every single user and see the info about every user just by doing /1/2/3, blah, 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 blah. That's a problem you shouldn't do. You should not put session IDs in the URL. So that's a good place to look first. Headers. There's a header, if you ever mess around with HTTP requests, called the refer header. It's used for a lot of verification to make sure that the request is coming from somewhere it's authorized to. If you can change that, you can maybe fool application to thinking you're someone, thinking you're actually that application, but maybe pass it, like come from your malicious website, something like that. WebSockets, I've done pen tests in the past where the people just let the WebSocket endpoint just be unencrypted, so you could see all of the events coming into the app just by listening in on this WebSocket and see everything happening. That's obviously something else you should do. We'll come back to that. Just if you're getting a few of these things that keep coming out as encryption, 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 you should encrypt everything that's data flowing in and out of your program. And that's, again, such an easy thing to do, but people still don't do it. Functionality from other websites. So if you include Google Analytics forms, I mean, yes, we can trust Google, but you have to keep in mind, I know it sounds crazy, but what if Google gets hacked and someone messes around with the JavaScript you're including in your website? And then guess what? Everyone using Google Analytics is screwed because there's malware being downloaded into users that are using your website just because of Google Analytics. So that's more important when you think of other things. If you're including from sketchier places or places that aren't as trusted, you have to think of that. It goes on and on. Now, I could keep talking about more input vectors here, but as web developers, we all know that there's plenty of places you can get stuck into the application. Okay. So the last part of the thinking like an attacker, at least in this little summary, is you have to understand the flow of data. So how does the input data flow through the program? So an example is data on page X is displayed on page Y and needs to calculate the result at page Z. If you can pull out these trends out of your application, then you can kind of see, okay, if I can mess with the data at X and then it's displayed on page Y, and the user goes to page Y and gets that bad data I put in, maybe I can take control of their browser and read all of their cookies, and then I can be that user because I have their session ID. The list goes on and on of things that you can do with just thinking about how data moves about the application. Another one is how does the output of the page flow through the program? So example, how is the result of a calculation used as part of a tweet? So maybe you post something on one part of the site and it posts it somewhere else. Can you do something with this side of the site to get it to pop up over here and affect this many people, or it keeps going on? Those two things are very interrelated. The point is just to understand how data flows about your application. It's basically that. So now that we talked about thinking like an attacker, that you can talk a lot more about that. There's whole courses that you can pay thousands of dollars just to like learn about that I haven't taken, but there's a few places that do that. So from there, you have to really know the basics. And so now I'm just going to go into a few of the basic vulnerabilities and stuff that almost always comes up in applications out in the wild. Okay, so I have a little bit of a legend for I read the next few slides. So if there's a blue box with a little yellow JS, then it means it applies specifically to JavaScript. I try to tailor these slides on vulnerabilities to the programming in general with any language, but I do have specific stuff for every way to fix something and how to do it in JavaScript, so that everyone that here does JavaScript, you can go and look at this later and fix it, or just know that it's there. In light blue where it's highlighted, just kind of point out more interesting things about how to fix something. Okay, so here's a long list, mini list. The basics, there's tons of things you can do, tons of things that are bad to have in a program. So injection, think of stuff like database injection, think of stuff injecting commands into the system, all that kind of stuff. Broken authentication sessions, are you handling your cookies correctly? Are you handling login, logout correctly? Cross-site scripting. Can I inject scripts into your website through a form and render them on a user's page and then steal all their cookies and again be that user? Exposing internal implementation details. Do you a response they return, does it tell something about the backend server? So in your Node application, do you send something back to the user in a response, like a whole entity, a whole object, rather than just giving the fields that they need? And that can kind of show people, hey, look, they just sent me an is-admin field. It's not used anymore, but what if I change it and send it back? And then boom, you're already admin. That stuff happens a lot. Bad configurations. Obviously, you can misconfigure your stuff. Like I talked about with those, with the baby, like the Barbie dolls and the cameras. They just didn't have encryption on the connection between whatever their endpoint was, their computer or their phone and the doll. If they had just set one field, installed one certificate on this application that would encrypt the connection, then you couldn't have seen that. I mean, it's more complicated than that, but someone that does that for a living would know how to do that. Exposing and leaking sensitive data. This is a big one. Too many people show really bad data they shouldn't show. Like you can get, I'll show you the demo here in a little bit. Like there's a part of the application that there is no link to it from the outside, but if you just crawl the URLs, you can find an internal reference to it. And once you get there, it's just a list of a bunch of numbers about users and their records. And I know that sounds crazy, like it doesn't happen, but if you go back and just look at the history of vulnerabilities, then you'll see that this stuff comes up a lot. And then not validating access to functionality on the server side, that's another problem. If you may think you're sanitizing and validating everything in the client, but if you expose an API endpoint on the back end and you just expect no one's going to find it and you don't protect it, someone can find that endpoint and call it and do bad things with your application. It's always good to know that you have those things. Cross-site request forgery is another one where essentially with CSRF, you can change requests that change state of applications. So like put in posts, you can basically change the data being sent in those requests and have it do bad things on your behalf. That's basically what that boils down to. And that has a super simple fix. It is one JavaScript middleware in Express, one line of code, one npm install, and you are protected from your users being compromised like all the time. So it's really simple, but people don't do this. What?
What is that?
CSRF. Yeah, have you heard of it? Yeah. So there's a few more. Using other people's terminal code, I talked about Google Analytics, where there's a library called Lodash that a lot of JavaScript people use. I've used it for stuff. If that ever gets something introduced into it and someone puts some bad code there, then I mean you're screwed if it's on your app and you're including it. You've got to update it as soon as you can. Redirecting forwarding using unvalidated input. Can you inject something into the site that will forward a user to your malicious domain that looks exactly like that domain and then put malware in your computer? That's another thing. The fix for that, we won't talk about that more specifically, but basically the fix for that is don't do redirects and forwards without validating the input you pass to them. It seems common sense, but people might think that that's not something that can be exploited. Over/under posting is another one. I was pointed this out by Josh Carroll. He said that's a big deal where people might send entire databases in responses and not remember to strip out what isn't necessary. I'll keep going in a second. My mouth gets way drier in these talks than I know. File inclusion. This is a big problem in PHP. Because PHP has tons of terrible stuff in it. I hate the language, but that's just my opinion. It's okay. It's fine to write in. I mean, I'm writing in it a lot for my senior design project, but it's because we're trying to fix it. File inclusion is a vulnerability where you can literally include a file from your website in the page. And what happens is people don't validate that, and you can literally go and inject something into this and start reading files in the machine. So if you're familiar with the Linux file system model, you can read etc password, which is /etc/passwd, and that will tell you every single user on the system. And guess what? If you run your applications as root, then if there's that kind of vulnerability, then you can do everything you can do as root. You can read every single file you want. And all it will do is put the contents of that file in that directory. That can extend even farther to remote file inclusion, and I can get a shell on your machine. So I can have a bash shell on your machine just like you do, and you'll never know it, because it will just look like another web user. So that's another reason why we don't run our web apps in root. Just please, my God, do not do that. Password management, that's another problem that still happens. In 2012, LinkedIn was compromised. I'll talk about that in a bit, but they had one problem with their password management implementation. They didn't solve their hashes. They hashed the passwords. They didn't encrypt them. Don't encrypt your passwords, because if your site gets compromised and someone steals the key, boom, all your passwords are unencrypted. But if you hash them and you don't solve them, you're screwed. You're still screwed, because it's easy to break those hashes and compute what the actual passwords are using rainbow tables. I won't get into that, but it's super simple. There's scripts that people already wrote just to do that. And there's a specific, John the Ripper is a tool, if you ever look it up, that just, you can point it to a bunch of hash passwords and it just starts cracking them. There's a few others, but remote code execution, that gets more into stuff like network security and compromising actual hosts. But that's where you can basically run code on the other machine arbitrarily. And that is a result of a lot of these other things. So file inclusion can help you do that. XSS can help you do that. A lot of these things can lead to doing that. And many, 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 many more vulnerabilities. We didn't even touch hardware security. There's tons of stuff. You can just rip open a Cisco router and start messing around with stuff, but they're smart and they protected it with trusted boot and a lot of modules they're supposed to protect against that. But those are things people have to think about.
I would also add HTTPS encryption is not just about being able for people to see what's the traffic on the network, but it's also to prevent spoofing. And that's what's happening a lot is a lot of web applications will have a main page where you enter your username and password, and they post it HTTPS.
Yeah.
But the main web application could be spoofed, and you could actually type your username and password into a false application.
Absolutely, yeah, absolutely. That's definitely a thing like that. I won't talk. Okay, but you could theoretically go to Starbucks on their open Wi-Fi, pull up a program that I won't name on Kali Linux, which is another operating system with a bunch of tools, sit there, and every person in the Starbucks store that's on their computer and visiting HTTP websites, I can just sit there and read all of the data they're sending. Everything. So imagine if Facebook didn't have the green guard, if it was HTTP and not HTTPS, then I could sit there and Joe over here log into Facebook, I could see his password is Joe and password. That's his two passwords. And believe it or not, that password is the most common password out there. But you could do that. So again, that's another reason why we use HTTPS. And this is pretty, like, if you're a manager, if you manage technical people, even if you don't do development and you get anything out of this, the encryption stuff, just HTTPS, SSL, TLS all the time. Encrypt everything when data is coming in and out of your application. And you also need to be careful to use, to not do, when you start getting into that, there's something called self-signed and trusted certificates. So you want to make sure you get a certificate that's valid and is trusted by people that validate it. And that you can read about that, I won't go into that here. But there's a lot of things you have to get right there, but there's plenty of tutorials to do it. And all of you guys work at companies that have the resources to do this, I'm sure. And I hope everybody uses HTTPS on everything, but a lot of people don't. So we're gonna be diving a little bit deeper into a few of the main vulnerabilities that I talked about. So cross-site scripting is basically when you run malicious scripts, JavaScript in the victim's browser and the target application. So successful XSS can steal cookies, session IDs, which are in the cookies. It can read what you're doing in the site. It can do anything that JavaScript can do running on that domain. And you can redirect people to your own website that looks exactly like that website and make them think they're on the website they think they're on, but they're actually on yours. And then they start typing in their passwords on your website, and they're done at that point because you can go to the real website, log in as them. Imagine if that was your bank, then I could just direct you to my crappy bank's website because it looks so terrible, and I could just do it in a night. But then people get on here, start putting their passwords in, and I start transferring all their money to my account. Just because in one form field in their massive website, they didn't check to see whether the username was validated. They didn't look to see, oh, hey, this person shouldn't be able to end the input field and start putting input script and input whatever they want into JavaScript. That happens a lot, and we'll look at that in a small demo we have. So mitigation, validate, sanitize all input, encode the output for specific context. I'll post all this online for you guys. So encode the output if it's HTML, encode it in URL, or if it's HTTP. URLs, you need to encode it with URL encoding. Just use the right encodings. You want to set HTTP only cookie flags and cookies that the client doesn't need to access. This ensures the cookies that should be accessed aren't accessed if they are stolen. So that's an example of how you can stop bad things from happening even if you have XSS. Another thing you can set, there's just one header called the content security policy header that will only allow certain client-side resources to be used. So if you set this, then it will stop certain scripts on your site from being executed if someone tries to mess around with them. And you want to apply encoding on both client and server side to prevent DOM-based XSS attacks. Where DOM is, like, you can think of the DOM in HTML, where it's basically doing XSS on the actual web application. And there's a templating language in JavaScript called Swig that has an auto escape mode that just escapes everything. And that does it for you. So if you use that, you're already done. You don't have to do anything else. CSRF, I'll briefly go over this. This isn't as big of a deal. It is, but it's kind of smaller. It forces the end user to execute unwanted actions on the web application in which they're currently authenticated. So attackers target state-changing requests. So think about if your website is a bank and it's vulnerable to CSRF, then I could get on there and put some bad stuff in a state-changing application. And the endpoint is that I could transfer, instead of $100 that someone like Jared transfer, let's see, we'll do the classic Bob, Alice, and Mary. Bob wants to transfer $100 to Mary. Bob wants to transfer $100 to Alice. And Mary comes in and says, hey, I'm going to mess around with the request and change it to $1 million to Mary. So instead of going to Bob, it goes to Mary. Instead of $100 to Mary, it's $1 million. That's something that's extremely easy to do when there's a CSRF vulnerability. And there is one library. It's one piece of express middleware. There's literally one line of code you have to include that stops that from happening. It makes it very hard to happen, and I've never been able to exploit CSRF just by including this. Basically, what it does is it puts a random token in with every request, and it makes the state basically hard to change. Yeah, if you get more into it, it makes sense, but basically what it does. So there's that. Injection. This is a huge one. It occurs when untrusted data is sent to an application or an interpreter as part of a command or query, and you can execute stuff on that they wouldn't have otherwise expected. So the really big thing here that a lot of people think of is SQL injection. So if you can, if there's a field that's showing a bunch of users, you can basically end, if it's like enter a username to see all the matching users, and in that user field you put you close off the quotes for the username, because they're just running an overall SQL query because we're assuming they're not sanitizing it. You close off the quotes, then you do or, basically it's going to be true, 1 equals 1. Then you will dump every single thing in that table, and that's how people get database dumps of your websites. They just dump all the passwords, everything that was in the user table. Just because you didn't check to see if that field was valid before you submitted it to the SQL interpreter. In JavaScript, this manifests itself a lot when you're doing things like eval, set timeout, set interval, and function. So eval specifically, if you're not sanitizing stuff into there, you can just run arbitrary stuff on the machine and through JavaScript. And you can read more about how you exploit the set timeout and those functions just by looking into more of this. I'll post all the links at the end. So the mitigation is just to validate all user input. It's super easy. There's ways to do this. There's libraries just for checking input to make sure it's correct. Okay, password management. This is really sad. People still don't do this. Passwords are often left in plain text or they're encrypted. The problem with encrypted is that if your key is stolen, then all your passwords can be decrypted. So it sounds great, let's just encrypt everything, but you have to be careful with what you're encrypting. I mean, you just don't want to, I'm terrible at coming up with analogies off the top of my head, so I'm not going to try, but just don't encrypt everything. Think about what you're encrypting. So an example is the 2012 LinkedIn breach. Passwords were hashed, but they failed to use assault. So with existing rainbow tables, I can download off any website that has these things, which I can pull up on my computer right now. It took a matter of a few hours to crack hundreds of thousands of passwords of LinkedIn users and go onto their accounts and steal their information. And that was done in a matter of hours, just because they forgot to do 1+ on the end of this hash. It said, hey, include this salt. It's not as simple as that. It's actually, it kind of is a little simpler. You just use bcrypt. There's just one function. It's called bcrypt. There's a JavaScript implementation right there. It's the industry standard for it. You pass in the data, you pass in a salt value, and you pass in 2 other things. They're just random numbers. They're basically random values. And it makes a hash that is basically, you can never get back from that hash to the original thing, no matter how long you just try and compute it. And it takes anywhere from, depending on the length of the hash, it takes anywhere from a number of many months to hundreds of years, longer than the universe's lifetime, just to crack passwords hash using bcrypt. Again, if we have quantum computers tomorrow, that probably won't hold up anymore, but for now we don't, so don't worry about that. And again, enforce strong passwords. I can tell this story because I'm in a web security class at UT. I probably shouldn't be taking it. It's a little too easy. But I'm in it, and someone from ONL is in my group is teaching the class, and he explained the ONL password policy, and I'll do it here because he did it. But he looked into cracking the ONL passwords for an entire national lab, and it would literally take 3 hours to crack anybody's password, given the way that they did it. And that's really sad because they have to conform to all these governmental red tape restrictions, like the numbers have to be here and here and here and here and here. And everyone's, hey, you shouldn't do that, but way up in the government, it's like, no, we have to have this because we're the government. We have tons of red tape. So there's that. Enforce strong passwords. Please don't make it be only 3 characters long. Please make them use something other than their old passwords. And make them use something other than anything off of their profile. There are things called password managers. That's why people wrote them. That's what this is for. Okay, so another one, using other people's code. We talked about Google Analytics. Imagine including Bootstrap's JavaScript files. If those get compromised, then you're out of luck if you use Bootstrap. Lodash. Another really good example that I heard the other day is way back in the early days of the internet when stuff was starting to get bigger and balloon up. Everyone had page counters. Like, cool, I had 100,000 people today and 200,000 tomorrow. What happened? People started to get evil. And this is when people really started to get mean and evil and did all kinds of bad things. Malware was being distributed through the page counters in everybody's website. So from a few people who made these page counters, hundreds of thousands of websites used them. And because grandmascookies.com had a page counter with 100 users, everyone going to grandmascookies.com was getting malware because the people had no idea what they were doing when they were including their code. So that's another reason to trust that. And if you guys think people are nicer now, you should think again, because people are not. And now that it's actually in the news now. This stuff didn't get in the news back then. So mitigation, don't get trust blindly. It's kind of easy for us developers to like npm install this and pip install that and whatever package manager install this. But you just have to remember that you're trusting other people with your users' data. And so you're giving your users are giving you their trust, so you should hold up that trust. Okay, so here's another big one, broken authentication session management. So basically, an attacker uses leaks or flaws in authentication or management functions to impersonate other users. So a lot of times developers will build custom authentication schemes. Like, I'm going to build my own like OAuth implementation because I think that's a great idea. So this is really hard to do. And on top of that, there's a lot of times flaws. And again, if you do like research in the survey of the history of viruses and vulnerabilities and malware and stuff, you'll see these things come up. So basically, there's a few simple fixes here. The mitigations are you protect user authentication credentials, you encrypt them, you don't send them, again, over unencrypted connections, you don't store them in the client side of your website for anyone to access. You don't expose session IDs in the URL. That was the AT&T thing where you could just iterate through the users and see all their banking info. You do not want to do that. Session IDs should time out. You should not be setting your session IDs to time out in 21,000 or 2100, whatever, because somebody might get it before then. You should recreate your session IDs after a successful login. If you have a session ID from login yesterday, you should just regenerate it and use it for that time. You shouldn't be saving these things for too long. So don't send session IDs and credentials over unencrypted connections. Use SSL or TLS. Again, this is hitting back on the point, you should encrypt everything. I don't need to keep saying it. And on top of that, you might authenticate everybody. Fine, you can authenticate everyone you want, but doesn't mean they're going to be authorized to use your resource. So the CEO of the company logs in just like I, as an intern, log in to the company, but I shouldn't be able to access the budget reports for the whole company. Only he should. And if you don't use permissions, then I could look at the budget reports. It's just as simple as that. So permissions, it's a big deal. So here's 3 quick links if you can check these out. I'm sure everyone's heard of Passport. If you use JavaScript, it's just authentication stuff for OAuth. Secure requests and headers. Helmet just adds a bunch of sick headers that do XSS protection, content security policy, a bunch of stuff that's really helpful. You can just put in the middleware and you're done thinking about. And then I didn't really find too many permissions libraries that seemed very new. But the newest one I found was this one by Optimal Bits that was permissions. And that's kind of nice. You can write that kind of yourself because you just restrict who's using what. And if anyone writes a Meteor, they have a really cool way of doing it where on each request you can allow or deny things getting through in the request. And that's a simple way just to check who's allowed on what requests to use what. So these are just important things to remember. First, authenticate everyone. Don't let anyone log into your Facebook account. And 2, make sure once you're authenticated to Facebook, you can't log into everyone else's Facebook account once you're in the site. So another one is over/under posting. This says check your privilege. So please check your privilege and don't send entire entities to the user when you're sending responses back. So if someone asks for a user, don't give them the entire user object so that it's easily modifiable and just resend back to another endpoint that just saves the new user. So that's, I was pointed out by Josh Carroll, who's not here. He told me this is a big deal and a lot of people run into this. Mitigation, follow the principle of least privilege. Don't do things, don't give people stuff you shouldn't. Only return parts that are required, and only update the parts of entities that are supposed to be updatable. And this means that don't allow workable users to change is admin in any entity. Like classic vulnerability things when you're trying to break into stuff, like little trainings and stuff will be like, hey, just mess around with this field and make myself an admin, change it from 0 to 1. And that's always like a nice intro to learning security stuff because you'll see that. Sensitive data exposure, this is really, again, don't have to say it, but don't expose sensitive data, encrypt it, please. Mitigation, use SSL TLS, encrypt all data at rest and in transit. Just because something is sitting in your databases doesn't mean the important stuff shouldn't be encrypted. Don't store or hash if it's a password. Don't store user-sensitive data unnecessarily. If you don't need their social security number, do not take their social security number. That is a bad idea. And especially, another good example is HIPAA. If you're a healthcare company, don't take their medical history from their mom when you don't need their medical history from their mom. And certainly don't store it unencrypted. I mean, you just don't. Use strong crypto and strong key management. If you're using crypto algorithms from 1995 when the internet first started, then please update your crypto algorithms. Most places will update it for you if you're following the right tutorials and stuff. But like if you're using Nginx and things like that, you can have a place to specify the key algorithms to use. I mean, this is where you get like Google Chrome and Firefox complaining your website saying, hey, this isn't using strong encryption because you have a cipher that's a month outdated now, and because Google updates like every 3 minutes as well as WordPress does. So there's that. Disable caching in forms that store sensitive data. Don't cache stuff when you shouldn't. Okay, so I have a little bit of time. If you guys stick around for like 5 minutes, I have a really quick demo. It's going to be just showing you there's a Node.js app that someone wrote called NodeGoat. There's another app called WebGoat, which is a PHP app. It's a very vulnerable app you can just mess around and play with. And I found someone did one in Node. And I'm going to use a proxy, it's something called Zap Proxy that's going to go and break it and do some automated scanning. And this is something you can just download one-off, and you can just start running against your site and see all the vulnerabilities in it if there are any. A big hint here is that a lot of times there's false positives. There's things that come up that aren't actually there, but it's still a good first pass on understanding if you have bad things in the program. Okay, so yeah, I will go back here. Sorry, I couldn't do that there. Okay, so we basically have our app here. It's NodeGoat, and I already set up a script using tmuxinator. If you use tmux, it just multiplies your sessions. I have this tmux script that will start this. So it's just Knox.js demo. It's going to start. Oh well, that's great. Demos always go correctly, and I know exactly why this is. Okay. Okay, so we're gonna start MongoDB. The problem is it was way nicer before. And that actually works. Well, why is that really my stuff? Okay, here's another problem. Is that I'm gonna get a part of now because does anybody know why it's in there? If anyone uses a terminal, it does not show that's just my password. So I think since I've gone so long, I'm just gonna. Cody, fix it. Yeah, they're supposed to, but they don't apparently. Okay. Wait, what is? I have no idea what's going on. Oh, I see what's going on. Okay, well, the context is really okay, so one thing that have your house or code because I'm underage, can't drink, they won't do the demo. Okay, so wrapping up, I hope you enjoyed my class. Rather than you against why you should not have these problems, but again, if you want to see me, I'll do that demo sometime. I'll post it online. You should get out there. I know a lot of us developer people don't like to talk to people. That's the stereotypes people think of us, but I think we're pretty social people. Knoxville B-Side is up in May. It's $20 for security conference organized by people, and there are like hundreds of them all over the world. It's $20 at Scruffy City Hall in KC. Then there'll be drink tickets. I think you get like 4 drink tickets, so 4 beers at a time. Just one day, a bunch of really cool talks. There'll be companies there, all kinds of stuff. Cisco's a sponsor, CodeStock might be helping. Yeah, CodeStock's helping sponsor a bunch of people. If you're a student, I think one of the students were my friends that I dragged here, and Alex. So if you're a student or knows So HackUK, my cloud just designed over there founded it because nobody cared about security, and I just told you to care about security, so we thought students should too. So the HackUK, if you know students, then to us. There's now like a mysterious ghost security meetup that popped up on Saturday that is in Knoxville, and if the person is here that runs that, please tell me because I'd love to talk. And that's the website, it's on meet.com. And if you're really feeling wild, go to Las Vegas in July to DEF CON, where you'll see hackers that, like, the actual hackers with their gauges like this big, and they have mohawks and pink hair, and everyone's like on drugs. I've heard really good things about it, and they present really cool stuff. Last July, there were people that hacked into the Jeep that were able to control it and take it over from someone driving on the highway where they're presenting their stuff. And they presented the first time there. So that's the kind of stuff you see there.
Still reading your devices.
Do not, yes. Do not. So in other words, Cisco, I think I asked my class, like, hey, if I work here full time, I bring my computer. Everyone's like, no, 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 no. Everyone's yelling across the office, like on the intercom. No, you can't do that. They like really travel, like beat their laptops, even with a nice MacBook steering while we're there. They give me these really terrible ones to take. Yeah, they were pretty old. So don't bring your devices as you go, because people will do this stuff. It's like a huge Starbucks with open Wi-Fi. Everyone will sniff your connection and read your stuff. Definitely don't be watching these sort of like bad videos, because they'll just put it up on the screen and you'll be humiliated. Okay, so there's that. I have a few credits. Just a bunch of people. I went to that. General resources is tiny, but this will be out. There's a bunch of really good stuff. And this one, there's some other scanners. I didn't get to show you the scanner, but it's like a one-click and it starts showing you cool stuff. And again, I'll show you that. Maybe another time they'll have me out. And here's some really good JavaScript stuff I dug up and stuff I've used before. There's some so the first one is that no joke in the tutorial has the top 10 vulnerabilities, some of the ones I went through, and the exact libraries and codes to include in your application to fix it. And it even includes the Express app and shows, hey, uncomment this code to fix XSS from happening in your app, blah, 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 blah. It just fixes everything. And the last quote I'm going to leave you with is by Kevin Mitnick, one of the early hackers that was arrested and now is like a law man for being a security consultant. He says, companies spend millions of dollars on firewalls, encryption, and secure access devices. It's money wasted, because none of these measures address the weakest link in the security chain. And if you learn anything from this, the weakest link in the security chain is you and I, developers of applications. So the more you know about these basic things, the quicker you can stop these things from happening, and hopefully they won't happen at all. So I think that's it. Thank you guys for having me tonight. Sorry, questions, if anyone has any? Yes. Oh, definitely. If you're not a KnoxvilleJS, please join KnoxvilleJS. It's awesome. And I'll send it to Chris. He can put wherever I'll put my slide.
And the talk will be on the KnoxvilleJS channel forever. So.
Yes.
Don't worry about it. Any more questions?
Do you follow Twitter at all?
Yes, I do on Twitter. Yeah, there's a few. Twitter gets stuck into that endless loop of like, cool, you follow this person, I'll follow you, and your follow ratio just goes to crap, and none of these people will follow you ever. But he's one of the good guys. Another person, if you want to know about security stuff, is Krebs on security. He's a security journalist. It's very high level. He covers security stuff in general. And another one, if you want a little lower level and more like the anti-government, like pro-privacy stuff, is Bruce Schneier. Invented some of the early cryptography algorithms, and he's all about like protecting our own data. And these are some of the people that have a lot to say in Apple versus FBI. So if you ever want to talk about that, come talk to me, and we'll have flame wars about it all day. So any other questions? Yeah.
How much do you like web to mitigate some of those risks?
Oh, so yeah, using tokens is a form of authentication. Like you can use token-based authentication. As long as you handle it correctly, that can help you with a lot of stuff. The biggest thing there is make sure you encrypt them. You're saying like a port, you encrypt them, and make sure you link your tokens. So the funny thing with that is like Twitter, these were API. You have to get their API secrets and tokens. And if you go and search on GitHub, you can find people that commit their settings files with their Twitter tokens to the API. So you can just scrape all these Twitter APIs and have like unlimited clients that come on the Twitter stream. So yeah, you have to have people who use them, but that's and in some of the apps I built with my friends, we use token-based authentication schemes for a lot of stuff. And like passively, I have a default OAuth server implementation built, so my build will run that. I know Python does. I'm a big fan person, and it does. So, yeah.
I guess I have a still question. I'm a student at UT, and a lot of companies are getting access to like HTTPS and having SSL. Is there a cheap way to just encrypt my website?
Yes. So, ta-da! There is the best thing ever that came out last fall. It's called Let's Encrypt. It's just Let's Encrypt, and anybody can use the service and secure their sites with trusted certificates. Because Let's Encrypt was a partnership between companies like Cisco, Google, Akamai, Amazon, Microsoft. They went in and said, hey, follow our powers and make a new trusted CTA, so a certificate authority. And they said, hey, everyone that wants a free SSL certificate can use one. And if you go, DigitalOcean is a hosting service. Even if you don't use DigitalOcean, Google DigitalOcean Let's Encrypt tutorial, and they have about 20. It's just like, how do you put these in your site? And it is literally, you download, it's a Go or Node file, I don't know which one. And you type like Let's Encrypt generate or something, and it runs it through nice GUI. You type the domain you want, press enter, and it puts the configuration automatically into Apache or Nginx. And boom, there's all of your problems with encryption solved. And it's just so simple.
You don't even have to have the Go installed. You just check out your hub and run the command from there. It's pretty simple. I just renewed my SSL certificate at Terra in like 5 minutes last weekend.
And you can even set, you can use cron jobs and make it automatically renew. I did that on the all-in-one but one. And now I'm getting emails from Let's Encrypt saying, hey, you already know your thing. So it's for a consulting, I'm doing. So in the case that it does go bad and they start yelling at me for turning red, you have to make sure you have it automatically renewing. But yeah, so Let's Encrypt is where you should go.
And it's free?
Free, yes.
Free open source.
Open source.
The problem with it is they don't do the diligence that you do with other SSL certificates in terms of identifying the company itself, right?
Well, I see what you're saying, putting in the information so they get to identify that.
So if you had that IBM.org
Yeah.
or whatever, and that you didn't really have that, you could kind of like falsify, make a fake site.
Yeah.
IBM.org, let's say.
Yeah, it just requires that you have access to the DNS, that the domain that you're registering for exists.
So
And the server that is pointing.
So somebody companies, Google, IBM, whatever, they've gone through a process that identifies them as that company. And that's what Encrypt is not doing.
Yeah, I mean, but it is only $10 from Namecheap to do that for for a regular certificate. So for everyone that has like their own apps that aren't worried about that, it's a good solution.
If IBM doesn't have IBM by word,
Yeah.
or by now,
Also, if you can get any website because they're all that time first and make the USA website.
Yeah, so if Symantec, whatever, the big yellow, they have a root CA, and they were sent out all the other CAs came on their butt and was like, hey, you guys aren't being secure because some of your employees leaked a bunch of your information. You're like private keys or something. So they got audited by all the other CAs, and you guys, Symantec, you suck. So there's a big like chain of like, it's a bunch of checks and balances between all of them. And it lets them get to the CA, so they do have a checks and balances. But I mean, if you really want to like get very certain, if you're like a startup and you're doing Google and you go big, you should probably buy a real one from like a few $100 for the most expensive ones. But for getting started, that's perfectly fine. And it's the green certification, and Chrome and Firefox will say this is valid. They won't complain at you, and that's the biggest thing. If you have people having to go to that stupid dialogue that says you trust this website, no one is going to use your service. So just make sure you're not in that bucket.
It's also worth saying that Google's going to start penalizing people's result ranking if you're not encrypted with SSL certificates. Just everything. Now that they count, there's a free solution people can do this. There's really no. I'm not sure if they did that ranking yet, but they have said that.
Yeah.
Penalizing them.
Yeah, they start like that when they initially, or they've done this with a lot of parameters, but they're first like, hey, anyone that's website isn't mobile responsive, we're going to penalize you. They've already started that. I know that for a fact. I've read that somewhere. And then with like the encryption, that's something they'll probably have soon, so it's better to have it now than later. And it's like a 5-minute process. I mean, it really depends on the internet connection. It's just quick download, run a script, and you're done. And you can do it from multiple domains. Even subdomains. So if you have like your blog.yourname.com, you can do it from that too. Any other questions? I'm glad to take any. I like talking, so I'll keep talking.
They also use some other operators.
Okay, yeah. So Amazon, and if anyone uses Heroku as well, it's like $10 a month for just automatic SSL on your app. And if you use a lot of these things have like a temporary hosting, like Heroku, you can do like myapp.herokuapp.com, and that's already SSL. Like you can just basically click one button and do an add-on for a certificate for your own domain as well. So again, if you guys ever want to have me out again or see me somewhere else, I will do that demo. I promise. I had 2 backup slides with like this is slide 53, so congratulations, you got through like 50 plus slides. So it's a lot of information.
What's your Twitter handle?
Jared the Coder. So like it was okay. So my brother makes fun of me. It was it's with like 3 S's. Jared's is like it's Jared, and I thought that was really terrible. So I changed it to that. And the problem is all my evidence was Jared Michael Smith, because another thing, if you have a common name, there's like 1,000 people making your name. Like it's terrible. So I tried to do Jared Michael Smith on Twitter, and it's like a max 16 character limit, or it's just like a few characters short of that username. So everything else in this username, and Twitter just decided crap on me, and I'll use that. So anywhere else, it's like jaredmichaelsmith.com and all that. And if you want to follow me on Twitter, I'm trying to post better stuff. So I try and tailor it to a lot of different developer things. Any other questions? Okay, thank you so much for having me.
So this is part of the meeting where I give out free things, but we don't have any tonight. And I'm waiting to tell you that now after the talk. So I'm going to thank Jared again for giving the talk. This is open. Anyone ever wants to give a talk or a presentation or anything, just come talk to me and we'll put you on there. Thanks to Cody and KnoxvilleJS for live streaming and recording this. This all works for hosting us. Bye, damn cozy. Reminds me of the beer. Next month, we'll be meeting here again. Alex is giving the talk. Some stuff that needs to come with the Meetup API. So that should be fun. We all use Meetup. That's why we're here. So that's everything that I got.